Hey all, now we'll be diving into lab 2 of Vertex AI. We'll be focusing mainly on two methods to deploy end-to-end pipelines. One would be your AutoML by using like AutoML deploying the pipeline, and the second one is bringing your own custom model and like creating a container, like create using a pre-built container for that model and deploying it to the endpoint. So first, let's see how we use AutoML to create this pipeline. As you can see, we are in the Google Cloud Console now in the Vertex AI tab. So if you go down to data sets, you can already see there is MBA data here. Okay. For this lab, we'll be using MBA admission data set. This is a classification problem. You either classify the admission and to admit waitlist or reject. So you download the data here and I'll show you how to upload it to the data sets. Okay. Now, just create and click on the create button and name the new data set. VA data. Now you select the data type. So clearly our data is tabular and our job here is classification. So I click on this and we select the region. It's usually better if you select the region that you are in. But for some reason, US East one was not having enough resources, so I've been using like US Central one for the whole like for the series of these labs. Okay, now you can see uh, you have to upload the data to this data sets feature. Now here, you select like since I've downloaded the data set and like uploaded it to my cloud storage in a bucket. So I'm selecting the second option. So here this is the Vertex AI Lab 2 bucket I've created and I've uploaded the MBA classification CSV here. And if you go here, you just have to copy the GS util URL and give the path to that data set here. Now you click on continue and you'll be able to find this analyze tab where if you like click on generate statistics, after a few minutes, you'll be able to find all the distinct values and the missing count percentage. So if you check here, this after a few minutes, you can find something like this, something similar to this. And now once you're done with your data, you go to the training part. Here you click on train new model. You give the MBA data, like if you create a data, like if there is any data in the data sets feature, you can directly see it here. And I'm click since we created MBA data, I can see the MBA data here and the objective is classification. Okay, now the model training, we choose AutoML and then in the next method we'll be choosing uh, custom training with the pre-built container. Now you just name your data and be a model. Target column is your admissions and continue. So you can play with your features and like add optional features after you get more features from an online store or create your features in the feature store tab under the data section. But since it's a very simple data, I'm not going to add any features here. So continue. Now, okay. For the training options here, yeah, okay. If you want to give more weight to one column, or if you want to distribute weight among columns, this is like these are the settings that you have to change. And you can also change your optimization objective, like your loss functions. Here I'm just sticking to the basic log loss function and then continue. Budget, we put like one maximum node hours and then we start training. So af- this after the training is finished, if there are no errors, you will be seeing something like this. Since it took like 3 hours the last time I did this training, I'm not going to do it again now. Once the training is done, you'll be able to see your model here, MBA model. Oh, it took like 3 hours. Now for the next part. Okay. So you can there are hyperparameter tuning jobs as well and the neural architecture search jobs. These both will be covered in the next coming labs. Now once your model is created, once your model is trained and created, you can now the next step would be deploying your model to an endpoint. So before that, we have to create an endpoint. So go to the model registry feature here and deploy a new section. You can see that the MBA model is already here. Now, if you just click on it, you can see the various tabs: evaluate, deploy, and test, batch project, version details, etc. Deploy the trained model. Here, you just have to click on deploy endpoint. Then you name your endpoint, MBA endpoint. Uh, Access is the standard access. And for model settings, it's pretty much I left them as default. You can like add more high GPU if you want if you want like low latency. Next, click on continue. You'll be given an option to enable model monitoring as well. But for model monitoring, it takes like minimum 24 hours to check the data. Since I'm just using a single static data set, I'll not be enabling this mod, model monitoring for this pipeline now. Sorry, after you create your endpoint and deploy your model to the endpoint, and your endpoint is active, you can see something like this. And so these are the set of instructions that you can like run it on the Google Cloud to get a prediction here. But I'll show you a bit different approach because I've already followed this in the README file. So okay, let's just copy this and open. Okay, so this is the Postman application that is used to like validate the URLs and all. And now, uh, I just okay, I'll do a new one. I just paste the URL here. Now you have the project ID. So if you go here, See your project ID. Just replace the project ID with the number, and your endpoint ID is also given here. Copy and then replace this with your endpoint ID. Okay. Now, once this is the okay, first thing we have to, since it's a post command, just change the method to post. Now, authorization. So, go to the bearer token. And here, open your Google Cloud Shell and then run gcloud auth uh, print access token. So just copy this access token and paste it in the authorization here. Okay. Now the headers. In the header section, we need to add a new key content type, and the value would be JSON application JSON. Yes. And now in the body is your data. So let's put raw, and I already have this data here. So let's just paste it. So this is one object of the JSON file, and I'm just trying to make a prediction of these values. Also, you have to make sure that uh, all the all the key value pairs are like strings here, like all the values of application ID or gender and like any other columns, always have to be strings. Sometime, okay, in some cases, this won't accept false too, depending on your model. So we'll talk about that more in the coming practicals. So now we just have to send highest score. So the prediction is reject here. Mm, okay. Yeah, we've deployed the train model using AutoML, and also there is a interface just below the endpoint section to make sure, like, to check if the values you give are giving right results or not, instead of like going to Postman or like running all the commands. So you can just use predict here, and you'll get a label. So now let's discuss how we can deploy end-to-end pipelines using our pre-built containers. So first, like open up a Jupyter Notebook instance, Jupyter Lab instance. Uh, Yeah, have your folder set up like this. So it's setup.py and a trainer package which has init file and the task Python file. Okay. Now for this lab, we'll be following uh, this page. Uh, As you can see, okay, I'll explain more about the structure and then we'll go on to the next steps. In setup.py, this file downloads all the extra packages that might be needed for your, like other than your pre-built container that might require for your task. So you have all the required packages downloaded here. And in your trainer, so trainer is you have to make sure that you have to make sure trainer is a package, not a directory. And by adding init.py, the trainer directory becomes a package. So
Now let's see about task.py. Yeah, in task.py, you have your main script that takes in your data and runs the machine learning model. So this is pretty much simple ML, simple ML training code. But only part that could be different is your input arguments. Here, parser, you can using parser you can add your data path where you need to get the data from. So in our case, it would be a cloud storage. We'd be giving it a bucket address, and this is given by the user while running the script. Now let's uh, go ahead and run this command. Okay, you have to make sure the terminal is open in the package in the directory. So you run this command, and now you'd be able to see another two directories created here. Yeah, distribution and trainer.info, info. So now we've created a source distribution. Then the next steps would be storing your data set into your cloud. So that we'll be using the bucket address where the data set is stored in the future purposes. Here I've already created the cloud buckets, and the data set that we'd be using for this lab is stroke prediction data set, downloaded from this link that is also available in the README file. Now, yeah, just create a bucket and store your data set here, stroke data.csv. All right. Now let's go back to Vertex AI training. Okay, here let's start with a new model. Let me just delete this existing pipeline. Yes. So in AutoML, we define this data, like we added this data in the datasets feature, but here we'll be doing it a bit different. We'll be selecting no managed dataset since we are giving it as an input while running the task or script, and automatically you will be eliminated with these options, AutoML options. So click on continue. Now name your model, stock model, and then continue. Here you can see we are selecting, like we are talking about pre-built container, and click on that. And this task for this the task.py, we'd be requiring scikit-learn framework. So I select scikit-learn model framework with version 0.23. Um, so for this package location, just go to the initial web page that we're following to create the source distribution. So if you go down, you'll find upload your source distribution to cloud storage. Just click on edit option, give your Google Cloud bucket address. Here, this is my uh, folder. This is my directory in the bucket that I'm trying to store the upload the source distribution. So I just copy the GS util address there and paste it here. Now I copy this command, go to your workbench and just upload this. So yeah, completed file one of one. Now you'll be able to see the .tr.gz file here. So, yeah, I think we just have to refresh it. Yeah. So now just copy the GS util URL and give it here. So the Python module, you remember we added an init file to trainer to make it a package. So now we can just the package and the Python file we're trying to. For the model output, we'd be creating a new bucket and like give the util GS util URL here. So just copy the URL here and paste it. Okay. I think that's it. Yeah. So uh, I created a new bucket and it is recommended to create a new bucket for the outputs and create a job outputs folder inside this bucket. And like I gave this address there. Now coming to the arguments, you remember we were using parser to give some arguments, like give the data as an argument. It's time we use that now. So yeah, now we just have to give the address of the data set in your cloud bucket. This is your distributions cloud storage path. This is you have to create a new bucket to store your job outputs. That is your model artifacts. Like in task.py, we are trying to save this model as joblib, and the save model file to not repeat any training and future purposes would be stored here. And in argument, you'll be giving the dataset address and then continue. So we'll discuss the hyperparameters in the advanced lab. So no hyperparameter tuning now. Now coming to the computer pricing, deploy to uh, we'll just use standard 8 CPUs and no, continue. So here this is a different this container is for us to use to serve the model. Like once the model is done, we can like create a web page, and for that, we can. This container is basically for server, so we're not using any container as of now. So no prediction container. So you can see the model is training. I think it will take like couple of minutes. Now you can see the training job is finished. Now we just have to deploy this model to an endpoint and get an online prediction. Now go to model registry. Since you haven't used AutoML here, you'll not be able to find the train model. So you can just import the model, name this as so scikit 23, and the model artifact is your
model job lib location. That that should be in your outputs. Model and job lib. Your copy. You're providing the model artifact location and then continue. Okay, let's not get into explainability now and import. Okay, we have to read first. Yeah, please check if the cloud storage. So before you're trying to give the model.joblib directly, but as it is mentioned here, you shouldn't give the part to the model artifact directly. It should be the folder. And now let's just click continue and import. This should work. Yes. So you can see the stroke model is imported. Now you just have to deploy this model. And you can follow the same steps while following like as of AutoML. Uh, so just leave these at default. You select the machine type and continue and deploy. So it will take a few minutes to deploy this model, and then we can go ahead and try to get online predictions of that.
Um, Now you can see that the endpoint is active and the trained model is deployed at this endpoint. Now we just have to test this uh, model by giving a sample data to get the prediction. And same and as similar to AutoML, we'll be using Postman here. But one thing to keep in mind is in our task.py, we've made some changes to the data categories. So all the data features, I mean, all the categorical columns have been like uh you have been one hot encoded. So we'll be having more than the initial number of features. To show you, initially in the dataset we just have 12 features, but after the split and after removing all the features and one hot encoding, we can see we have 21 features here. I'm telling this because it is important to make sure we give the same number of inputs that the model is trained on while testing it also. So we have to make sure. So you can also test your model here in the GUI itself. If you can see, I use the same format that is provided here, except for I use dict instead of list. So sorry, I use list instead of dict, and I've given like 21 parameters. I mean 21 features here. And also if you can see the bool values are changed to zeros and ones. I've tried with false and true too, but I've been getting some errors. So finally, if I change them to zeros and ones, so I'm getting the prediction. Now let's just try to paste this URL here in Postman and check if we're getting a prediction. Here it is, we are getting a prediction, but it's inside the Google console, right? So we're just trying to see if we'll be able to get a prediction online. New request. Again, it's a post command. Uh, Copy our URL here. Just copy the project ID that you can see here and replace the project ID with in this block. Same with the endpoint ID. You can see the endpoint ID here. Mm, Yes. Right. And yeah, authorization is same bearer token, and we'll get the authorization key here. Uh, just run gcloud auth print access token. Now you have the access token. Just paste it here. In the body, try giving the modified JSON file. So modified, not JSON file, but piece of uh, JSON file. Can it can be a piece of JSON file. Here I'm just testing it for uh one row. So let's try and send to see if I get, yeah, and we are getting a prediction 0. So this is how you can use your build you use pre-built containers or frameworks in GCP and build your custom model and deploy it. One main thing one main thing to remember while using AutoML is it could be easier, but it takes up a lot of uh, it takes up a lot of resources and it is a bit costly too. So be sure that you are aware of the cost before using AutoML. And yeah, that's it for this lab, and we'll be continuing with more advanced topics in the future labs.